Hello, this is Mr. Stein, and in this video we're going to look at example problems 3 and 4 from section 6.2, slopes of parallel and perpendicular lines. By the time you're done this, you should be able to determine the slope of a line parallel and perpendicular to a given line. So I give you the line, you determine the slope, you can figure out if it's parallel or perpendicular. You can figure out the slope of a parallel or perpendicular line. You can judge if two lines are parallel or perpendicular given their slopes, or points on the line. You can determine the location of points to give you parallel and perpendicular lines. All right, let's head over to example problems 3 and 4. Letter A. Determine the slope of a line that is perpendicular to the line G and H. Okay, so we've got point G and H. So let's take a look at where G is. G is at -2, -3. That's right here. H is at 1 and -2. Right there. G and H. There's G and H. Now, before we can determine the slope of a line that is perpendicular to it, we have to determine the slope of GH. So let's determine the slope of GH using our formula. y2 minus y1 is equal to over x2 minus x1. This is point 1, this will be point 2, and let's zoom in here so we can see it. y2 is -2, subtract -3, all over 1 subtract -2. So -2 subtract -3 is going to be +1, all over 1 subtract -2 is 3, +3. So the slope of this line is 1 over 3. We can see that here. It's 1, 3. Okay. Now, what we want is we want the slope of a line that is perpendicular to this. So we're going to write that down. So perpendicular to GH means that the slope would have to be the negative reciprocal of this number here. That's a positive number. So we're going to have -3 over 1. Okay. Determine the coordinates of J so that GJ is perpendicular to GH. So we have to find out where we can put J. So can I put J here so that GJ is perpendicular to GH? I can't put J there. Where can I put J? Well, there's lots of places where I can put J. Now, we're going to do this visually on the graph. We know that GH, so our line that is perpendicular, our perpendicular line, has to have a slope of -3 over 1. So if we start at G, and we start drawing a line that has a slope of -3 over 1, so down 3 over 1, right there's one possibility for J. We go down 3 over 1. Right there's another possibility for J. Any of those points would be a possibility for J. We can even continue this going the other way. There would be a possibility for J. So we have lots of possibilities for J. So point J has to be on the green line. Could be anywhere on that green line. So example, it could be at -1, -6. It could be at 0, -9. It could be at -3, 0. It could be at any one of these in-between values with decimal numbers. But one of the things that we can do is we can write the equation for the green line. We can write the equation using our formula y equals mx plus b. And we know the slope of the green line is -3, and the y-intercept is right here at -9. So our formula would be y equals -3x subtract 9. So J could be anywhere on this line. And if J is anywhere on that line, then the line from G to J, the line from G to J would be parallel to the line from G to H. So if J was up here, G to J would be parallel to G to H. All right, so let's take a look at example number 4. EFGH is a parallelogram. Is it a rectangle? Justify your answer. Okay, this one we're going to do visually. So let's take a look at it. It is a parallelogram that they say. That means this side and this side are parallel, and this side and this side are parallel. The question is it a rectangle? That would mean that these would have to be perpendicular. We need perpendicular lines. Well, let's quickly go through and let's determine the slopes for all of our lines. So the slope of this line right here. I just grab my 2 points. I go 1, 2, 3, 4, 5. Plus 5 is my rise over a run of 2. So 5 over 2 is my slope of that line. Let's look at this line from G to H. It should be 1, 2, 3, 4, 5 over 2 as well. Those are parallel lines. They have the same slope. Now let's look at E to H. Our slope is equal to, it goes down 1 over 3. And lastly, our slope down here, -1 over 3. Now the question is, are these two slopes negative reciprocals? So let's look. M is equal to -1, 3. And the negative reciprocal of this is equal to +3 over 1. And +3 over 1 does not equal 5 over 2. Those are two different numbers. So this is not a rectangle because two adjacent sides are not parallel. So it's not perpendicular. A rectangle because the adjacent sides are not perpendicular. All right. I hope you found this helpful. And if you have any questions,